Thank you. All right, so the talk today is billion calls with a modern software stack. Hello, everybody. My name is William King. It's great to be here again. You might recognize me as the founder and senior engineer of Quintus Technologies, or as one of the previous core developers of FreeSwitch. Saw y'all last year and had the pleasure of the privilege to join the Flowroute team as their chief architect and taking on the task of establishing an office of the CTO. I brought with me today our VP of Product, two of our senior engineers, and our CEO. And you can meet them in the back. I'm sure several of you have probably already had conversations. Brief technical history of Flowroute as a company. Flowroute was founded in 2007 in California as a SIP trunking reseller, providing professional services. I became a customer in the middle of 2011. 2012, Flowroute moved its operations to Seattle and implemented a new business model. 2013 became a certified software-centric carrier. With a lot of hard work, Flowroute's received many awards for its support, best practices, and innovations. Our random facts, our downtown office is just a few blocks from Pike's Market. 60 employees, about 40 of which are software developers and technologists. And we've got a 98% CSAT, so customer satisfaction, and a plus 67 NPS, so a net promoter score. So our customers seem to really enjoy what we do. Flowroute's vision. We see that there's a shift from siloed, closed, device-centric networks to open, contextual, relationship-centric communications. That means an increasing number of tech organizations that are deciding that communications are strategic. Flowroute helps these organizations scale, operate their platforms, and creating a comms infrastructure, both PSTN and otherwise, to allow our customers to focus on what's important for their end users rather than reinventing the wheels several times over. To do that, we've had to build some of our own superpowers. Some of these involve using modern software development techniques such as continuous integration for testing, continuous deployment, though not in its purest sense. We have a few manual stages where we want to pull the trigger, but the majority are automated. Specifically, testing with SIP-P for SIP scenarios and testing customer configurations, load testing end-to-end and per component. My primary role is on the patent strategy and administration, technical product architecture, building and managing relationships with external subject matter experts, and customer technical collaboration. Our goals are successful onboarding, speedy, smooth issue resolution, scale and automation, excellent customer experience, and delivering new capabilities quickly. We do this with our hyper network. It's a combination of technology, deployed best practices, SEC licensing statuses, and our business relationships with our partners. On the technology side, at each step on the physical network path of routing, we've architected a level of fault tolerance as well as adaptive and selective load balancing and routing. We're able to keep routing even after major services have gone down. We've identified a particular class of traffic. If we've identified a particular class of traffic that we need to reroute for a specialized manner, either increased diagnostics or higher priority, et cetera, we've got that flexibility built in. We've been granted 2 patents on parts of our hyper network with a handful of already filed and many more in preparation. Our license CLEC status, we have access to US telecom specific databases such as LURG and MPAC. Business relationships allow us to, in each US rate center, arrange and reserve and use surplus overbuilt switch tandem capacity. That allows us also to have redundant physical network path for inbound. A close mental equivalent, if you're probably familiar with using an LCR system for outbound calls, we're able to do this on the origination side and do this for physical path rerouting to the internals. I'm here on this presentation to share our experiences, to innovate on behalf of our customers, not to give advice necessarily for best practices. Do my best to leave some room for questions, but I am available later for follow-ups. This is a zoomed in, one region, simplified piece of our diagram. We can scale this horizontally easily and in multiple different regions. Looks like it's almost readable. Each instance has a local cache of the data that it needs for querying. When the caches grow too large for provisioned memory, we segregate it out into subclusters. This architecture allows us to keep physical paths within the same region for those columns. So when a customer, say, with one device has a firmware update causing weird behavior, or a carrier updated and is giving corrupted headers, we can selectively route based on the inbound calls to a particular diagnostics instance where we may have turned up debug logging. And this gets around the issue of needing more information, but not being able to run debugging in production at that level. Doing so with CI/CD testing, each box represents a logical service for us. Each instance has a defined interface of upstream, of what it's consuming, downstream of what it's producing, and specifications for its error tolerance and timing. Some of the client routing capabilities over on this side, we're able to use IP import, A records, SRV records. We're able to hairpin back to the PSTN, also be able to do SIP registrations. Having these defined interfaces allows us to use and define to our engineers what situations need to be unit tested, what situations need to be load tested, and we can evaluate the performance requirements based on the customer configurations. So breaking down this functionality into more detail and how it's tied back into Kamailio. This is our SIP registration cluster built for an active-active scaling and zero downtime deployments. When it comes to handling the registrations themselves, we try and take the philosophy of being strictly valid in what we send and generous in what we accept. Customers want to route their calls based on their SIP registration presence. We provide ways for them to register with the same credentials simultaneously from one or more locations. The thing about dealing with inbound registrations from customers is multiple different types of systems. Some of them have broken implementations. For instance, sometimes they repeat or don't properly increment a C sequence when they're trying to re-register. How do you handle that? For some clients, they don't send a re-registration at all. They send a new registration and expect you to have expired the old one and replaced it with a new one. So we've built out in these different layers detections to be able to use some level of testing those scenarios. As we scale up and deal with multi-region and different fault scenarios, most fault-tolerant systems have to be able to keep an authoritative state in memory, synced between nodes of DMQ, with a single node responsible for streaming these changes, in this case the user lock writer, to a SQL database. This way we can expose the state in memory to customers through a web API. The AWS RDS Postgres instances over here as the user lock is only used for showing the registration information to customers, and in the worst type of disaster scenario where if the entire cluster and there is no state left, we can at least bootstrap to get close. That reduces a huge level of waiting for customers needing to re-register in the worst case of disaster. Huge range of load tests. Having containerized the above functionality, we're able to easily turn on CI/CD testing knobs to evaluate the services, different levels of load, different ranges of data sets, performing operations under the load, such as node inserts and removal. Okay. As an operational component of pulling nodes in and out of service, you can see the spike on the top graph was the DMQ replications. As we pulled a node into service, we'd see a massive spike. These active transactions need to be provisioned ahead of time with shared memory and other resources. So we went out to see, could we reduce it so that our budgeted levels mapped more closely with the production business case for this service. For the user lock writer, which is responsible for the one-way synchronization, we found that other database types, such as MySQL, had support for upsert, while the Postgres driver in Kamailio did not. The upsert functionality is valid because it gives the application a way to insert, check if it failed a particular uniqueness constraint, and then if the item already exists, replace it with an update so that we get the latest data into the database without flooding the logs with a bunch of spurious errors and failures. So rather than dropping the table and resynchronizing, we're able to, if the user lock writer, in our case, were to go down, we're able to restart it, and it's able to quickly get a differential into the database. And now we have a much more quiet log. Okay. When dealing with continuous deployment, one aspect that needs to be evaluated is the performance of the system under load. SIP-P can be used to run a range of valid and invalid call scenarios and registration scenarios. It can also be used to record latency times per call attempt, outputting that information to a CSV file. This CSV file is on the latency between two timers. That information can be processed into any kind of a statistical analysis application. For folks who have used SIP-P before, you'll know that it's not optimized as Kamailio for generating and receiving SIP traffic. But if you can spin up a higher ratio of SIP-P endpoints to attack your platform, you can push over any particular service or node. One reason the latency information is important because it's the early warning system before SIP processing and SIP response failures occur. So it lets us do statistical analysis on those variable changes. Part of our CI/CD pipeline, we can actually classify it into the ideal scenarios. And now with the ideal removed, we're looking at what we would consider same graph as before, ideal removed, zoomed in on the degraded, and then the failed. When you're dealing with performance issues and you're looking for a needle in a haystack, trying to tune and trying to tweak and look at multiple dimensions at the same time, having a smaller haystack really helps. And again, same data, zoomed in. Okay. In this particular case, we were trying to look at things like kernel thread or process context switching, or looking at whether or not having one instance block writing to disk caused anything. So we see spikes of one processing thread with multiple messages getting stuck and then being able to release itself. And of course, this was pushing the system way over its design capacity. And here's an example of the statistical data we can use from that information. This one was produced with R, the scripting language R. Thanks to our data analyst, Anna at Flowroute, we can see whether or not there was a statistically significant change between our baseline and our experiments. Now that we have these different computed quantitative values, we can automate the testing of a wide range of variables simultaneously. We can define the range, we can define the interval, and get back the data in an automated fashion. For instance, when doing a git bisect to try and track down a commit in a subsystem, in a library, you can try a new kernel, you can try a new version of some dependent application and get back the stats of which one statistically changed and how it affects us without having engineers disappear for 2 weeks to a month. You can't optimize what you can't measure. Okay. How it all comes together to improve the DevOps reaction times is having access to multiple sources of data in our production systems. We're able to, this is a screenshot of GitLab, though it doesn't render so great. We're able to collect all the information, specify service logging, things like AWS Kinesis, as well as continuous SIP tracing with things like Home or SIP capture. On each logical service, we can stream those logs, zoom in, collate the information together, identify the differences of what might have happened in production, and then when the engineer is actually logging in to look at the situation, having all of the context around the scenario identified. We can then determine whether or not it's a platform-wide, a customer-wide, or per source or per destination type issue, and quickly hone in on the differences. Yeah. When dealing with a localized stability issue, whether in testing or production, it's possible to automate the process of backtrace collection and analysis, such as if you've seen this particular type of crash before, you can get a fingerprint of the stack trace. If the engineer is looking for an automated way of, we've pushed out a new set of configs, ran the load test, stability issue, where on the config file, reg in line 278, did the stability issue happen? Okay. And that speed lets us do things like join AWS Marketplace in their SaaS contract launch in the middle of April. There's only one telecommunications carrier. We're able to move quickly and join in a lot of public-facing and customer-requested situations. So now, if you were to use the AWS Marketplace, you can provision or pay for your telecommunications spend as a line item on your AWS bill. And then thank you to Julian, Anna, Kristen, and Chris, who helped with the presentation. Questions?
What I wanted to say before going to the questions, because Julian is here, and actually he did a lot of commits to all these modules that, I don't know, maybe you can put the hands up. Thanks for the contribution lately to the DMQ and the other modules, Julian. Okay, so questions now before I have mine. So here we have Armin.
So I guess my question is, what's next for you guys?
I'll defer that to our VP of product later.
Is that?
There are a bunch of very interesting, fun projects from a technical perspective in the pipeline, but which ones we release and in what timing, I'll defer.
I have to say, I'm not going to tell you right now. But there are some interesting things in the background, so expect some announcements in the next few months.
And next year, Kamailio World. We'll come back and.
Okay, thank you. So from the perspective of, I don't know, maybe Julian will take it or not. How is this distribution? I saw when you show it on the graph, you have a spike. What would eventually help from technical point of helping with that from the project itself? It's DMQ with, I think it's using JSON format. I don't remember because it was a guy doing it initially. And he also contributed like packing because we had a single record. There are a couple of events or like modes to replicate. But do you find this flexibility good? Like instead of just eventually writing a connector for RabbitMQ to use the SIP way, because I use it and what I like there, but okay, I'm maybe biased. Here, I like that I can even decide how to write these DMQ generated modules by, filtering with Kamailio config file. Is that a good flexibility offered, or are you seeing that maybe the SIP overhead it's adding to the? Shall I give it to you?
No, I think it's really great because we benefit from the speed of Kamailio with SIP messages, and we can compress further or optimize the replication of multiple contacts per message. And it's blazing fast, just like Kamailio is with SIP messages, so we get the best out of Kamailio with this, I think. Maybe tuning the timers to be longer. In case there is a delay, we don't want to rush into retransmissions, some little things, but this is really fast and can take a lot.
Okay. Thanks, because somehow I'm not really a fan of these binary protocols. We have the binary RPC that was added in the past by some of the SIP Express router guys, but you get always in some troubles when you pack it and it's hard to route those packets. We'll always like static routing, and I was more into, and it's why we added this JSON RPC as the main control, not for this case, but I kind of started to skip what's kind of, hard to digest as a human and hard to route it with existing tools. So writing everything from scratch. Okay, then thank you guys. Again, there are a couple of them around here from Flowroute approach. And once again, thanks for supporting the event. and contributing code to Kamailio.